Current in a conductor is a result of the movement of free electrons in a material. Electrons move within a material through the use of a property known as electrical charge, symbolized with the letter Q. There are forces that act between charges called an electric field that will repel particles with the same charge and attract particles that have opposite charges. Coulomb's law describes that a force exists between two charges that is directly proportional to the product of the two charges and inversely proportional to the square of the distance between the charges.
I know. Some of you are probably saying,
This is analogous to Isaac Newton's inverse square law of universal gravitation. But where gravitational forces are always attractive, electrostatic forces can be attractive or repulsive, which is what Charles Augustin de Coulomb is describing here.
and if you're like me going through this for the first time, you're probably saying to yourself,
What now?
all it means is, okay, you see these magnets? If I move them so that the negative poles of this one faces the positive pole of this one, then they attract. There is a force that is attracting these two magnets together, and the further they get apart, the weaker that force is, and the closer they are, the greater the force. And that's what Coulomb is describing in terms of particles. A coulomb is also a unit of measure for a charge. Remember Q? Well, Q is a coulomb. An amount of charge can also be calculated if you are given that an electron has a charge of 6.25 times 10 to the 18 coulombs. So if you know a certain number of electrons, you can calculate the overall charge, or I guess if you knew the charge of a material, you can calculate how many electrons there are in it. Okay, remember this is all about voltage, current, and resistance. An electrical charge is a big part of understanding that. You will not need to calculate how many electrons are flowing in the capacitor on the job, but an understanding of electrical charge is important, and things like polarity must be understood, and more importantly, followed.